Hi there, Turgeon here, bringing you physics from afar. You should be looking at this Mcas practice test answer sheet. I'm about to teach you a lot and give you a lot of answers. Make sure you're writing extra on that sheet. Momentum is a quantity based on mass and velocity. The Acela train has a lot of momentum because it has a lot of mass and velocity. So go ahead and plug into the equation. You're going to get 140, you're going to get 144, you're going to get some other numbers for these, but the biggest answer is going to be the biggest answer when you do the mass times the velocity. And remember, if you click on exhibits, you can see all these Mcas equation sheets. You can see P equals momentum right here. You can see that P equals mv right here on the equation sheet. We'll get to the calculator later. Okay, number 2, this is called Coulomb's law. Remember, you're writing extra. This is all about forces between the charges. The forces will be bigger between the charges when the charges are close. So this, to me, is a really big force because those two charges are really close to each other. So these two, that's going to tend to make it a bigger force. This is going to tend to make it a lesser force. This is somewhere in the middle. They're the same charges, so that distance is really going to make a big difference. If we had really different charges, like if this had said like 10Q or something, then you're thinking that might be a really big force. But in this case, the bigger force is the one where they are closer together. And yeah. Here's one that was a miscellaneous topic, and all I want to say is a current and a wire together make a magnet. So check this out. If this wire has electrical current flowing through it, these compasses will respond to it and they'll move, which means it created a magnet, also known as a magnetic field. So a current and a wire make a magnet. A magnet and a wire make an electrical current. So if I take a magnet like this and I move it near a wire, which is often in a coil, you'll see an electrical current as indicated by this ammeter here. Remember to write extra. So the answer number 3 says that the moving electric charges cause a magnetic force. Moving electric charges is electric current. Here we can see that P equals mgh if they're asking me about potential energy. And although kinetic energy is 1/2 mv squared, you don't really need to know that. You just really need to know, oh yeah, look, this is the highest, because M and G are the same everywhere, so that's the highest gravitational potential energy. Then that's all going to get converted to kinetic down here. This one is all about net force causing acceleration. Net force causes acceleration. So you can see that we have a net force going upward because these two forces cancel, cancel, cancel. Now this doesn't cancel with the 4 newtons though, so we have an acceleration upward because we have a net force upward. Net force causes acceleration. Make sure you're listening, by the way. Don't just yes, I'm saying write extra, but I'm also saying listen to the teaching that's going on here. Okay. Ooh, 4 minutes already. Positive test charge. Basically, all that matters here is that we have forces. You know that opposites attract, and you know that like charges repel. So we have a force pushing on another charge here, and because they're both they're not opposites, they're like charges. Because they're both similar charges, that means that the force is going to repel. It's going to push this one to the right. And then as they get farther and farther away, that means because of Coulomb's law, there's going to be a lower force. So remember that force is related to distance. So if they get farther away, the force is going to decrease. Number 7, we're going to use V equals IR. If the voltage is 12, that means that to get a current of 2 amps, I need a resistance of 6. This resistance needs to be 6. So only one of these produces a resistance of 6, and you can see which one produces a resistance of 6. By the way, this is called series, and the resistance is just these two added together. Change in velocity is acceleration, so the biggest change in velocity is right there. If it doesn't have to be going upward, it could have been z going downward, but z is not very steep. So the biggest change in velocity is right there. We can see that the object is increasing its position, but as it goes in the beginning, this rate where it's increasing is not as fast as this rate. So it's increasing its position at a faster rate. Velocity is increasing, and the forces on the object must be unbalanced to make it accelerate like that. In this one, we're just going to use the work as force times distance equation. Again, that's found right here in exhibits. If you just look it up, work is force times distance right there. So the most work performed, just do the math and do the force times the distance, and you're going to see which of these is clearly the greatest. Here we have a bunch of different things going on. So the gas is, why is Cami like disagreeing with me all of a sudden? It's being difficult. So gas is at Z, solid is here at this line, which isn't labeled. A liquid is at line X. It's gaining potential energy through Y. It's gaining kinetic energy when it's a solid. It's gaining potential energy through W, gaining kinetic energy when it's a gas, and there's one more here, gaining kinetic energy when it's X. And when I say it's gaining, what I really mean is the molecules. So as we add heat, keep adding heat, the solid, the particles in the solid, the molecules, gain kinetic energy. Then they reach this plateau point, and then all of a sudden, the particles are gaining potential energy as it changes solid. They do not raise temperature. Remember that fact all the way up the chain, but the section of the graph where it's going from a liquid to a gas is between this liquid here at X and this gas here at Z, so I guess you know the answer. Now we get a bunch of explanation, This is important to know, that when it bends, if you look at these angles, that this angle inside is less than this angle. The angle of refraction is less than the angle of incidence. But those are just words. I mean, you can see it in the diagram. Definition of a wave, they carry energy. Then it asks us what could we get based on this information. If all we know is 12 hertz is the frequency, then that means we can find out the time for one cycle was the period, which is the period and frequency. This one's hard, but only because of the ugly exponents, and we're really not sure as physics teachers how much they want you to do this, but I guess they did it last year, so maybe they'll do it again this year. But we're using v equals lambda f. You're supposed to kind of know that the speed of light is fast, and you can look it up here on the equation sheet. It's 3 times 10 to the 8th meters per second. Wait. Supposed to be, there it is. 3 times 10 to the 8th meters per second. So we can plug in 3 times 10 to the 8th, and then we're trying to find the wavelength lambda, and they tell us that it's 4 times 10 to the 4th somewhere in this description. 4 times 10 to the 4th. Okay, so we just putting it in the equation, and you can see what I did here with this calculator. I'll do it again. I did 3 times second function 10 to the 8th. I hit this arrow here, and then I did divided by, and then now I'm going to do 4 times, and then second function 10 to the 14th. Hit the arrow, parentheses, enter. Now, you may not recognize this. You may not remember your rules of exponents, but this is the only one with a 7 and a 5, and it's really, really tiny number. And if you move the decimal, you have to move it 7 times. So there's your answer. This is one we didn't talk about a lot. We don't think it's that important, but I'll tell you now. the waves bent around this gap. So there you go. You can sort of observe that. And that's called diffraction. This is the first time we're mentioning it. It's one of those categories of topic that we think that the state is not being very clear about. And then as we look at constructive interference here, what's causing constructive interference? It's the fact that wave crests are blending with other wave crests. So that's just like saying, they say wave crests, but like we talked about amplitude in class, when one amplitude meets another. So here we have this free response. They give you straight up, give you the information, and you can just calculate the velocity of the wave. They ask you to look at this, and you can see in the diagram the deep water waves are farther apart. So there you go. And then for part C, we're comparing the velocity of the waves. Well, you can look at it, and you can see that if they tell us that the frequency is the same, but there's a longer wavelength here, then that must mean from the equation, longer wavelength would result in a longer velocity. This is me teaching you about alpha, beta, gamma decay. Alpha decay, alpha, beta, gamma decay are just different things that happen to nucleuses, to atoms, but specifically the nucleus of the atom. And what happens is in alpha decay, it generates energy when it spits out this particle, and the particle is actually a helium nucleus. It's 2 protons and 2 neutrons. Oh, I look at this and I'm seeing 2 protons and 2 neutrons, and you can see that this one lost 2 protons and lost 2 neutrons and it's kicked off this much smaller little atom nucleus thing. So so that's alpha decay right there. Beta decay is when it releases an electron, and because it releases an electron, that means a neutron became a proton. But oh look, this one releases an electron, so there you go. And then in gamma decay, the nucleus gets excited literally, and then it releases a photon, releases a little bit of light, and so that it doesn't change. There's no particle in the same sense. It's a photon, which is a particle of light. So there you go. Now you can do those choices, and you just learned about decay. This one's pretty straightforward. It's a motion equation, but it's a slightly different equation. But I want to point out that yes, you can find that equation here. It's one of these, but you can also use the equation that I taught you, or you can use logic to figure out that it starts out and then it increases its velocity by the amount of the acceleration. You can use the equation, the one I taught you, A equals V final minus V original over T. This one's like logic. They're like, oh, I know this is going to speed up, and then I know this is going to go at constant speed, and then I know this is going to slow down. So there's only one of these where it speeds up and then it goes at constant speed, and then it goes and then it slows down. I wonder if do they say that it's actually going to come to a stop? Anyway, they don't say it's going to come to a stop, but you can see there's only one of these where it speeds up. This may look like it's slowing down because but that's still speeding up at the end, so it's not that. This one is tricky and confusing, so let me help you. Basically, they're just asking you to say that it's a gravitational force. We know that there's a greater force between Venus and Earth, because this one's kind of tricky, and I'm going to simplify it a little bit. But if you look back, and here you should be writing extra, if you look back, the gravitational force is like the Coulomb force. The gravitational force is based on the masses and the distance, just like the Coulomb force is based on the charges and the distance. So I can see that, oh, there's a greater mass for Venus, way bigger than Mars, and there's much less distance. So it's got to be between Venus and the Earth. Now, by the same logic, the force is, yeah, it's going to be proportional.